How do we balance redox equations in acidic or basic solution? First things first, electron transfer reactions are called oxidation-reduction reactions or redox reactions. Balancing a redox equation is one step more difficult than balancing standard equations. So I would be assuming that you know how to balance standard equations. Equally important, I am assuming as well that you know how to assign oxidation numbers. This video will explain how to balance redox equations in acidic solution and in basic solution. When you know how to balance redox equation in acidic solution, then balancing it in a basic solution would just be a walk in the park for you. And I'm going to show you why. Let's balance the following redox reaction in A, acidic solution, and B, in basic solution. The first step in our balancing of redox equation is to divide the skeleton equation in half reactions. When we say divide into half reactions, we divide the equation into reduction reaction and in oxidation reaction. To help us identify which is the reduction or oxidation reaction, we need to identify the oxidation numbers of all the atoms involved. Silver here is a neutral atom and not bonded to anything else, so its oxidation number is 0. Oxygen is -2 most of the time, and there are 3 of them, therefore nitrogen would be +5. Silver ion here is +1. Oxygen is -2, and so nitrogen would be +2. Again, I am assuming that you know how to assign oxidation numbers. We can detect reduction reaction when the oxidation number will be reduced and an oxidation reaction when the oxidation number will increase. Since we see an increase in the oxidation number of silver, so we can say that silver was oxidized. On the other hand, nitrogen was reduced. Oxygen is neither reduced or oxidized in this example. So, we can write our reduction reaction and our oxidation reaction. Next step is to balance atoms other than hydrogen and oxygen. This is the same method when we balance standard reactions. In our reduction reaction, other than oxygen, we see one nitrogen in your left side and one nitrogen in the right side. So nitrogen here is already balanced. We don't need to do anything else. But just for example, in case we have this reaction where we have one nitrogen on the left side and 2 in the right side, we need to change the coefficient in the left side so that we can balance the nitrogen. As for our oxidation reaction, the silver is already balanced. Step number 3 is to balance oxygen by adding water molecule to the side that needs oxygen. Also, balance hydrogen by adding hydrogen ion to the side that needs hydrogen. In our reduction reaction, there are 3 oxygens in the left side and 1 in the right side. Therefore, the right side needs 2 oxygens. We can do that by adding 2 water molecules. But since we added 2 water molecules, hydrogen is introduced in the right side. Therefore, the left side needs hydrogen as well. We can balance hydrogen by adding proton or hydrogen ion to the left side. Since we have 4 hydrogens on the right side, we will add 4 hydrogen ions on the left side. In our oxidation reaction, there is no hydrogen or oxygen, so we will just leave it like that. But do remember that in the presence of oxygen or hydrogen, we will add water molecules and hydrogen ions as needed. Let's proceed to the next step. Balance the charge by adding electrons. Look at the left side of the reduction reaction. Hydrogen ion is +1, but we have 4 of them, so times 4, so that's +4. Nitrate is -1, so if you add them together, you will have a charge of +3 in the left side. As for the right side of the reduction reaction, nitrogen monoxide and water molecule are both neutral, so they have no charge. So, positive 3 on the left side and 0 on the right side. We can balance that by adding electrons, but where should we add the electrons? You see, if we add 3 electrons on the right side, we will get negative 3 on the right side since electrons are negatively charged. But then, that's not yet balanced with the right side because they have different signs, therefore they are not equal. But if we add the 3 electrons on the right side, which will cancel the positive 3 charge, we will get 0 charge on the left side, which is exactly the same in the right side. As for our oxidation reaction, silver is 0 because it's neutral. On the right side, silver ion is positive 1. So to balance that, we need to add 1 electron in the left side of the oxidation reaction. And all our charges are balanced. That concludes step number 4. Step number 5 tells us to multiply half reactions to make the number of electrons equal in both. Remember that we added 1 electron in the oxidation reaction and 3 electrons in the reduction reaction. We can make them equal by multiplying the oxidation reaction by 3 so that the 1 electron in the oxidation reaction becomes 3 electrons, which will make it equal to the 3 electrons that we added in the reduction reaction. As for the reduction reaction, we can just leave it like that or simply multiply it by 1. Multiplying the oxidation reaction by 3 will give us 3 silver ion, and 3 electrons. There you can see that both our half reactions have the same number of electrons added, which is what step number 5 wants us to do. Now that we have the same number of electrons for both half reactions, we are ready to combine reactions to come up with just one redox reaction. We add the right sides of both reactions together and we will combine both left sides together. For the next step, we cancel anything that is the same on both sides. Here, we cancel 3 electrons because they appear on both sides. And that is how we balance a redox reaction in acidic solution. You can stop right here if your job is just to balance it in acidic solution. But we need few more steps if we will balance it in a basic solution. So if we want it to be in a basic solution, we need to continue to step number 7. We add to the both sides of the equation the same number of hydroxide ion as there are hydrogen ion. Hydrogen ion is what makes the reaction acidic. So since our job now is to balance it in a basic solution, we need to replace H plus with OH minus. So we will add 4 hydroxide ion on both sides. I repeat, on both sides of the equation. Next step is to combine H plus and OH minus together to form water molecule. Since there are 4 hydroxide ion and 4 hydrogen ion, we will get 4 water molecules. And for the final step, we cancel any water molecule that you can see that appear on both sides. In our left side, there are 4 water molecules. In our right side, there are 2 water molecules. So we subtract both by the smaller number of water molecule, which is 2 water molecules. And finally, we get our final equation. You will notice that you were able to balance it in a basic solution this time because of the presence of hydroxide ion. This is the ion-electron or half equation method of balancing redox reaction. So keep solving, everyone. See you again next time.